Hello, today is December 3rd, 2021, and I'm going to show you my solution to Advent of Code, day 3. And I'm going to be using Erlang, the language that is used also by WhatsApp. And let me go to the place where I left my code. CD 2021, day 3. What is... sorry. I have to go first to the Advent of Code folder. CD Advent of Code, CD day 03. And let me open a browser window too. I'm going to go to Advent of Code 3, and I have probably said that I don't like that this is dark mode, but now I can see it in light mode. So the input is, let me show you this. This is the input. What do we have to do? For instance, here. Oh, sorry, where's my pen? I lost my pen. Yes, it should be here. It's not working. Okay, let me try again. Why isn't it working? This... now it's there, but it's not working. So I have to do it again. Oh, it's the second time I've been having problems with this Wacom tablet today. Let's see. Okay, now welcome to 27. Okay, so now I have it. Let me. So it says, so if you have here 1, 2, 3, 4, 5 zeros, and 1, 2, 3, 4, 5, 6, 7 ones. So the most common bit is 1. So you put 1 here. Next, 1, 2, 3, 4, 5 zeros, and 1, 2, 3, 4, 5, 6, 7 ones. So sorry, 7 zeros. So the second bit is going to be a 0. And here it goes. So now I see that if you have the length, this is going to be represented as a list. 0, 0, 1, 0, 0, 1, 1, 1, 1, 0, and 0, 1, 0, 1, 0. You could be counting zeros and 1, and when the counter for the list, the number of zeros or 1 is higher than half the length, you could say, oh, okay, this is the character here. But Advent of Code is not something that requires this kind of perfection. So the goal here, I did it brute force. So I counted zeros, I counted ones, and then you get to 1, 0. Here you see you have more ones. Here you have more ones too. And here you have more zeros. 1, 2, 3, 4, 5, 6, 7 zeros. So this is the first number. This is a binary in decimal. It's going to be 22. And I discovered today that there is a list. Let me, I'm here. Let me open another one here, but let me show you my code. Where is, yes, it's this function. It's list underline to underline integer /2. If you do, let me go here. Oh, sorry. If I do list underline to underline integer one, it's 10110, right? And 2, 22. So this converts a string that represents a binary number into a decimal number. I didn't know that. I learned it today. And the second part of this first, the second part of the first part, because every advent of code problem has two parts, is that if you have 10110, you could just do 01001, which is 01001, which is 9. So this is 9, and the result is 22 times 9, which is 22 times 9 is 198. So you see, there's all this. So, sorry, this is not my code. Where's my code here? List to enter. Yes, it's here. So this is the solution to part 2. Yes, part 1 I did it in a different way, but yes, for my, let me show you my code here. I'm going to leave the link. You see here the 198 is the result for the input from the problem description, and for the file that Advent of Code gave to me, the solution was this. How did I implement it? It was, this code is not beautiful. It's very, very ugly. So I receive a list. The list here is something like this. It's this list. So I receive a list. What do I do with that list? First I generate an accumulator, because if you take a look at the example from the description, it has numbers, binary numbers with 5 digits, but the input file has numbers with a lot of digits. I didn't count, maybe 10, maybe 11. And I wanted to generate an accumulator which was a list containing several zeros. So for this, I took the first element of that list. So I made a supposition that, an assumption that if this has 11 digits, every binary, it makes sense, right? From the description. Every element has the same amount of digits. And I took the first element, I calculate the length. So in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For the input from the description, it's only 5. So I generated using lists duplicate. So let's take a look at lists duplicate. If I do lists duplicate 10, 0, gives me a list with 10 zeros. 10, 1, 1, no, 100 is too much. 15, 1. So it repeats the same element several times. I'm going to use this accumulator here. I wanted to use lists fold left. That's maybe a problem, but I wanted to learn how to use, because I had seen many solutions or some solutions using lists fold left. So that's why I kind of forced it. Maybe that's why this code is so ugly. So first I generate the accumulator, then I got the size of the list. So you see for the input, the real input that Advent of Code gave to me, it's 1000. For the input in the description, this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is what I calculate here in size. And that's, yes, that's so confusing. I use it lists fold L to count zeros in that list. I believe I have a test for that. Yes. What does zero counter do? If it gets a number like 111 and the accumulator is 000, it returns 000. Why? Because there is no zero here. But if the accumulator is 000 and it receives 0101, you see here the 1 is an increase because previously it was a 0, now it is a 1. Let me add another test here. If the accumulator was 1, 2, 3, and I have 100, it will give me 1 because it was 1. Here is 1, it remains 1. It was 2. Here is 0, it goes to 3. It was 3. Here is 0, it becomes 4. Let me run that code. Yes, I have to go here. I copy this command here. I paste it here. I run it, and all the tests should have passed. Oh, what did I do wrong? Maybe I wrote the test 1, 2, 3, 1. Yes, it's 1, 3, 4, because it was 2 with a 0, it becomes 4. So this is a zero counter. It counts the number of zeros. You see, this is an auxiliary function that's going to be used by lists fold left. So it will apply zero counter to every element of the list, but accumulating. That's why you need an accumulator. So let me run it again. Okay, all tests passed. So the result of this processing here is for each the first element of the list. For example, here, sorry, here it's going to be 1, 2, 3, 4, 5, 5 zeros. This for the second element 1, 2, 3, 4, 5, 6, 7, 7, and so on. So it counts the zeros in the input for each column of the input. And then let me see if I remember here. So yes, here I did something that probably I shouldn't have done too, but it's I applied this anonymous function, which just see, yes, I just counted the zeros, and I verified if the number of zeros was bigger than or equal to size div2. So half the number of elements of the list. Yes, zeros is the list, and I applied function. What does this return? Let me show you. It returns something like that: true, true, false. So it means that the first column has more zeros than ones, the second column has more zeros than one, the third column has more ones than zeros. So that's the meaning here. After that, I call calculate numbers, and the test also helps me to understand calculate numbers. I just okay, so you have 0. So here it's going to be 0, 0, 1. And then this is a very bad way to transform this into an integer. So 001 means, actually it's the opposite, right? It's 110. Yes, I believe it's 110, because function bool is true. Yes, this code is so bad I don't even remember everything that I did, but it's something like that. So if you receive a list of Boolean values, it will give you a number, and you see there is this function, this call to the calculate number functions, and I'm using the same function but using a function which I called opposite bool. So true is 1, false is 0, and opposite bool is the opposite. False is 1, true is 0. Okay, but how does calculate numbers does it? It receives a function, it receives a list with Boolean values, and it basically, this is a very ugly way to calculate. You see, if the function applied to a Boolean value, so it's going the result of this is going to be 0 or 1, and this is a power of 2. So it's going to be 2 to 0 plus 2 to 1 plus 2 to 3 plus 2 to 4, and so on. Like when you do if you do 11001 and you want to convert this to an integer, you do something like this, right? You do, sorry, no, it's something like this. You ignore this one, but you 2 to 4 to 3 to 0, which is, I believe this is 0, no, 1, 2, 4, 8, 16. So 16 plus 8 plus 1, which is 25. So this is a very, very, very bad way, but I used list fold left again. So, and as this is using math power, which is 2, so math power or math pool, it's 2 to 4, it's 16. You see, it becomes a float. 3 to the power of 2 is 9. So it's a float. The result is a float. And you see the result of list fold left, which is in Elixir we use reduce. The result of list fold left is going to be a tuple. Why is it a tuple? Because I'm passing the largest number and then going down until it becomes a zero. It's not a, this is ugly. I know it's ugly. But after that, I trunk the result and I have the correct number. Yes, today was not a good day to solve this because I started doing, then I went to do some other thing, then I went back. It took me a lot of time and the result was very ugly. Here, the zero counter, I just apply a function to every element of the string and I just subtract because you know that, let me, this is kind of great, right? So, sorry, let me clear, let me call Erlang. If I do lists map and I call it fun of x returns as the number that represents the character 1 to minus x, and I do it to 110, the result is going to be 001. Was that what I wanted? Why? Yes, because I'm just counting. Yes, it just yes, I'm counting the amount of zeros in this binary. So here I have 0. This is 0 zeros, 0 zeros, then 1 0, 1 0, 1 0, 1 0. This is also ugly. After that, after I have this count, and then, yes, I use it also list zip. What does list zip do? It gets two lists, 1, 2, 3, for instance, and A, B, C, and it transforms into a list of tuples. And after I had this count and the accumulator that you have already seen where the accumulator came from, it's a list of zeros. Then I apply the zero counter several times, and the result is you just sum the current number of zeros to the number of zeros in this string, and then you have a new accumulator. This is very, very ugly, very confusing. Part 2, I tried to do something a little bit better. So, see, to solve part 2, I created two functions, calc O2 rating and calc is Kruber rating. That's what's written here. The description, you don't have to read everything here. I just went to the example. It was easier for me to understand the example. And then I said, oh, okay, I have to calculate one thing, calculate another thing. Then I will convert this thing to binary, from binary to integer, sorry. And then I multiply these two values. To calculate the oxygen rating, I have to, this is a common pattern, right? You just have a list and you start, because list is, yes, list is a list of binaries as strings. And then the description of the algorithm says that sometimes you because in this case, let me show you again the example, but I'm going to do, not going to explain everything here. But in this case, the idea is that you have a list of numbers, and then you say, oh, I don't want this one, I don't want this one, I don't want this one. Okay, second row, the first, how do you say, first round, you eliminate some numbers and then some lines. Then the second round, which is based on the second column, you eliminate some too, and the third round. And the idea is that in the end, you are going to have only one number. So that's why the how do you end calling calc O2 rating when there is only one value in the list? If there is more than one value, then you have to do some processing, which includes, yes, that's also something that I learned today, which is lists partition. For instance, suppose you have a list like 1, 2, 3, 4, and you want to partition that list by saying that funx such that x is greater than 1. So it partitioned the list into two parts: those that are larger than 1 and those that are not larger than 1. So you must have a function that receives only one argument and returns a Boolean value. I don't know what happens if you don't return a Boolean value. Yes, you have to return a Boolean value. If it was larger than 3, it would be different. So I did that partition because I wanted, that's what it asks. It says, oh, you need to separate those that start, but this is true only for the first round. So I'm going to change the name here. It not starts with 0. Get those with 0. Let me run the test again to see if I didn't break anything. No, I didn't. So those that have a 0 in a very specific position are going to one part of the partition. Those that are with 1 in a very specific position, which is the one given by the index, are going to the other part of the partition. Let me try this. I believe, yes, this is something I learned too. Yes, so my code is still ugly, but it's getting a little better. So if the NF, I don't know how to say that in English. This is a string, right? This is a binary number as a string. Suppose this string is 1100. If you ask for the first character, it's going to be 1. The second character is going to be 1. The third character is going to be 1. The fourth character is going to be 0. The fifth character is going to be 0. And 0 here, you can write like this. So, good point. Lists nth, it's 1 based. It starts with 1 until the end of the string, which is the right thing to do, right? You should never start counting from 0. So you do that, and you separate into two groups. Did I add? No, I didn't. Sorry. You separate into two partitions, and then you have to call it recursively. How? Because as I told you, you have a list. So first you have all, and then you have a smaller subset of this, and then this, until you have only one. So when I call it recursively, first I have to increase the index because the index is, for instance, if you're looking at 11000, then this is the index is 1, then it's 2, then it's 3 until the end of the string. And if you call it with 0, no, sorry, then you have to decide which of these lists I'm going to choose. That's where next list enters. So there is a rule that okay, if you have only one element in that list, that's it. If you have the first list is larger, the size of the first list is bigger than the first list, otherwise it's list 2. And you see here, you see that there is, maybe it's almost the same thing, but I didn't stop to think if I could join these two functions into only one, because okay, so you call it recursively until you have only one value, and this is for calc O2 rating. Calc scrubber rating, it's almost the same thing. I believe the only difference is that this is not different, and this is, let me rewrite this too, and it's with 0. Is it different anyway? Probably the only difference is it's here, because everything else seems to be the same. Okay. No, it's not worth it. Not for this code, which I probably won't ever see again. But the important thing here for me is what I'm learning every day. So I'm going to, let me just git add day 03 2021 Erlang, git commit some improvements, some small improvements, and then git push origin name. That's it. I was taking a look at this one by someone called Danila Gama. It's on, do you know there is an Erlang forums? Erlang forums is great. And here you can see, now this is from day 2. I'm going to take a look at day 2 later. But where is day 3? Day 3. Yes, it's here. Yeah, it's kind of hidden because there is nothing new. And then here you can post your solution. Okay. Yes, I noticed that the Nila Gama's code is breaking. It works for everything else, but it's breaking. How do I view? I want to, yeah. Oh no, sorry. Yeah, that's it. You see, they use that. No, that person use binary split and lists folder again. I don't know what binary split does, but probably this is the best thing, is to use the capabilities that Erlang has for binaries. I didn't use that. Most list, I took that from that for my code. Bits filter. So there are better solutions out there. Mine is probably, but the most important thing here is that I learned a lot from by solving. Where's my code? By solving this advent of code. First, I learned how to do it in light mode because dark mode is terrible. And second, because I learned some functions here. So that's it. See you later. Bye bye.